Alright, so I'm going to show you how to solve problem number 2 on practice D. And this is asking you, this is one of these problems with an orbit. So we have t equals 2 pi, and then the square root of r cubed divided by g, constant for gravity, and then the mass of the planet that's being orbited. So if we know these things, we can figure out, if we know all the variables but one, we can figure out that variable. So this one tells us have a period of 125 minutes. That's this one right here, t. But we have to remember that we want to change this into not minutes, because the period is going to be seconds, so we just times this by 60. And we're going to get, I think, 7,500. Let me double check with my calculator. 125 times 60. Yep, 7,500. Okay. So then that gives us our first thing we need to know. That's 7,500 seconds. That's our t. And then what we want to figure out, what distance, that's going to be our radius. Okay. Now we're going to figure out this radius, and in the end we're going to have to minus the radius of the Earth, because that's really where gravity starts. So we need to also have a few things about the Earth, the radius of the Earth. If you look on your book on page 250, you see the radius, the mean radius of the Earth is 6.38 times 10 to the 6. Let me put this in. Okay, the mass of the Earth, going to need that. That is 5.97 times 10 to the 24th, really big number. And then we got g. So then we just need to rearrange this equation. So first thing we got to do is get rid of this square root thing. So we times both sides, or we square both sides. So we just go like this, and then this. That gives us t squared. We square this. 2 times 2 is 4. And then pi squared. Then everything underneath here is, the square root is gone. So then we're r cubed over g, mass of the Earth. And then we just need to rearrange, so we want to know what distance the radius. So g and m are going to go over next to t. G, m, t squared. And then we're going to divide underneath 4 pi squared. And then that gives us r cubed. But we just want r, so if we just do the cube root of this whole thing, then we'll get the answer. So what I'm going to do is I'm going to move some of this stuff. Put this up here. Then we just need to solve, put all these numbers in. They're pretty big, so you got to see it over here. I'm going to start with g, 6.673 times 10 to the negative 11th. And then I'm going to times it by the mass of the Earth. I have that over here, 5.97. And that's times 10 to the 24th. And then I have this 7,500, and I got to square it. So I just do my math here. I don't think my small calculator will do it, so I'll just do it right here. You won't be able to see it, but that's fine. And that gives me 5.63 times 10 to the 7. Okay. And the bottom stuff I don't need to worry about because it's 4 pi squared. I'll just divide it all in once I get the top part done. And so I have that, and then this is going to give me cube root. So then if I do the top, what I'm going to do though is I'm going to multiply, not put this all into my calculator, I'm just going to do the coefficients. So if I do that, let me get my calculator up here. So if I get 6.673 times 5.97 times 5.63, that's going to give me 224. So I'm just going to kind of write that up here. And then I'm just going to multiply it. I'm going to add the exponents to figure out what they would be. So negative 11 and 24, that gives me, because you're adding them, 13. And then 13 plus 7 gives me 20. Right? And then I can then make this into a scientific notation that is real, a number between 1 and 10. So I got this decimal here, I go 1, 2 places, I'd put it here, 2.24. I made this 2 smaller, so I make this 2 bigger. And then that becomes a 22nd. So my answer for the top is 2.24 times 10 to the 22nd. Now I'm just going to divide it by 4 pi squared. Now what I can do is figure out what that is. So 4 times pi times pi, and that gives me 39.48. Okay. And then what I can do is I can actually change this into scientific notation. So this becomes 3.948. So I made this one smaller. I'll make, it's going to be times 10 to the first. And then I'm just going to do my division now. I have 2.24, and I divide it by 3.948. So 2.24 divided by 3.948. That's going to give me 0.567. Make sure I round this. Yep, 7. And then it's times 10 to the, so I got a 22. I'm going to minus this one when you're dividing. It's going to be the 21st. And then I have to make this one into a number between 1 and 10. So then I move it. I make this one bigger by 1. So I make this one smaller by 1. And it becomes 5.67. That's kind of an easy way. You don't have to go crazy with your calculator. And then I just need the cube root of this thing. That you're going to have to use your calculator. I'm sure there's an easier way. I'll have to mention to Mr. Frenchu if there's an easy way to do this if you don't have the calculator. Then if I just do the cube root, so then we get an answer. It is 8.28 times 10 to the 6, like that. And then I have to figure, this is the total distance from the center of the Earth to the satellite. So then we just need to take this number, the radius of the Earth, and subtract it from this. Okay, and whenever you do that, exponents stay the same. So you would just take it like 8.28 times 10 to the 6th. And then you minus 6.38. I'm going to erase this a little bit. times 10 to the 6th. As long as they're the same exponents you can minus, you just minus this number or this number from that number. So then we just go 8.28 minus 6.38 comes 1.9 times 10 to the 6th, that stays the same, meters. That's how far above the Earth. And that's your answer. I tried to share some of these scientific notation ideas with you to sometimes make it easier. I think when you start using it this way and really using the rules for adding and multiplying numbers with scientific notation, it gets easier than kind of relying on a calculator and making mistakes. So let me know if you have any questions. If you need me to do any other problems from your review, let me know, and I'll see you in class.